to like put your questions in at any time. So feel free to do that. I'll be manning the chat and the Q&A feature as well. Both will reach me. I let our darling panelists just focus on their presentations and answering your questions. I field them and get everything all settled. For those that don't know me, I am Mikey Prosciutto. I'm one of the YPs here at SWANA, and I'm in charge of planning the webinars. Uh, Today it's all about renewable energy and how to make solid waste industry a lot more sustainable, and then different options you have both on landfills that have been decommissioned and then those that are actually active at the current time. Um, with that, I figured it would be a good time just to mention that WasteCon registration is open. It's October 21st to 24th at Grapevine, Texas. For those that don't know where Grapevine is, like myself, it is actually just outside of Dallas. So it's going to be in a great spot. I will say October is a much nicer time of year to be in Dallas. It's not nearly as hot. I've been there in the summer and July specifically, and it is a force to be reckoned with for sure. I was wondering why the guys were working in the middle of the night, and I realized the heat really is something. So you're at there at a great time, and it'll be a great time. The next webinar, we're actually on a summer hiatus, just because everybody starts traveling around this time of year. I was born right near the 4th of July, so I know what it's like when everybody's just gone for a week. So I have no webinars planned for the summer, not until later August, September. But we will be doing the Career Day series for the YPs. Aaron Olton is putting those on. So feel free, if those are of interest to you or YP, feel free to reach out to me or Erin herself and get YPs into that to help with career day, building, career development, all those really nice things that we like to do for our young professionals. Um, and without further ado, I'd love to let our panelists introduce themselves first before they get into their presentations. Chris, I already see you're unmuted, so if you just want to jump in first and introduce yourself, feel free. And then Andrew, introduce yourself, and then take it away with your presentation right off of there.
Yeah. Good afternoon, everyone. My name is Chris Hiller. I am currently with Waga Energy, and I've been in renewables for about 23 years now. I've decided to make a career out of renewables, and worked kind of across the country on a variety of projects for commercial and industrial customers, and am now putting together solutions at landfills and treating landfill gas and converting it to renewable natural gas. So I'm happy to be here.
And I'm Andrew Carl at Revision Energy. I have been in renewable energy for coming on 10 years now. Before that, I was a mariner for about 10 years. And, you know, when you spend a lot of time on the water or really in the natural world in any way, you start to see the accelerating changes that the planet is going through. And um, I, I had two kids, and I said to myself, a person really should do what they believe in. And to try to make the world a better place to leave to our kids. And so I got into this field about 10 years ago, and I've been doing commercial and institutional sales and design since then. Huge thanks to Andre and to Mikey for setting this up and getting everybody together today. And I'm excited to chat with everybody.
Fantastic. So the floor is yours. Feel free to share your screen, get everything rocking and rolling. I'll be in the
Great.
background as the resident MC. You'll see me again during Q&A, where I'll be fielding the questions. Again, all questions are fair and welcome. We're happy to do that. And Andrew's going to take it away with his presentation first. Uh, Perfect. And then Andrew, the floor is yours. We'll be doing presentations for the first 30 minutes, and we'll transition to the Q&A later. So if you have questions you prefer to hang on to, that is fine as well. But Andrew, with that, the floor is now officially yours. So take it away.
Great. So we've done a lot of landfill solar here in northern New England, and that's what I'm here to talk to you about today. There's a lot of opportunities to, make use of landfill space that is otherwise going to be unused. It can't be developed into other things, and could potentially work with, gasification technology and, other regular operations at your landfill. So with that, let's get into it a little bit. First thing I'd like to do is just introduce you a little bit to my company, Revision Energy. I should say our company. We're a 100% employee stock ownership program, so 100% of the company is owned by the workers. We are in Massachusetts, New Hampshire, and Maine. We got 2 branches in each state. We've been around since 2003. we're a mission-driven company. Our mission is to make life better by building our just and equitable electric future. We're a certified B Corp, and even amongst that global community, we continue to get annual high ratings for Best for the World certifications. We are looking forward to continuing to accelerate the renewable transition here in New England. So one sort of first question that always comes up when people are thinking about solar anywhere in the United States, except maybe in the Southwest where everybody knows there's killer solar gain, is my area a good area to invest in solar? Do we get enough sunshine? Well, one way that we like to talk about it is by drawing your attention to Germany, which as you can see on this map, has a lower solar access to solar energy for PV than any place in the continental United States. Germany is a great leader who often exceeds 100% of their energy generation with renewable energy. A huge portion of that is solar. Everywhere in the United States is good for solar. We can talk a little bit more about financials later on, but even in some of these northern climates in the United States, we have cooler weather but plenty of sun, which solar operates better in cooler temperatures, and so even some of these northern areas can meet or exceed generation in southern areas of the country during certain seasons. The main components that we've got in a solar array, the solar panels, which literally when the photons come down from the sun and strike the surface of that solar panel, many of them will turn into an electron and flow across the surface of the crystal and into the bus bar and turn into electricity. So it is directly taking photons, turning them into electrons, which become electricity. And then the inverters, which take the DC electricity that flows from those solar panels, converts it to AC in order to pump it into your facility or back out onto the grid. When we are looking at designing solar for landfills, as everybody here knows, I'm sure, nobody would appreciate it if we came and drove piles or ran ground screws through the cap and into your landfill. So all of these systems have to be completely built on top of landfill caps when we do that. And so they're ballasted. There are two main methods of ballasting a solar array. One on the right is, by pouring concrete into a form in place. And the other way, which is becoming more common these days, is a galvanized wire frame filled with riprap. And again, that sets right on top of the landfill cap. And all of the wiring is usually laid in wiring trays or is laid upon the ground, and then additional earth built up into a mound over that electrical equipment to meet an 18-inch minimum electrical standard for buried equipment. But it's all done without impacting the integrity of your landfill cap. So when we first look at a landfill, we can see sort of all of this capped area, over on the west and south side. And, to me, this looks like, 1.5 megawatts of available, solar area on that landfill. Well, when we look a little bit closer, we see that the contour map doesn't look quite so attractive. It turns out that these ballasted landfill arrays can only be placed on areas that have an 8% grade or less. So all of this very light colored area, in this shape here is below that 8% grade threshold. And so what you end up with is a system that looks something like this. This ends up being about 800 kilowatts, so about half of what I, would have initially thought by looking at the satellite image. I know lots of landfills, have steep areas all over, and so finding that flat area and placing the solar there is the way to go. I know a lot of people see a south-facing slope and they say, "Ooh, can't we just, put a bunch of solar panels along that slope?" And unfortunately, it's not that simple. And then when the project is built and complete, this is what it looks like. You can see those ballasted feet under the solar panels. You can see this area of gravel in the foreground, which is the buried electrical equipment, where we've built up a mound in order to protect the electrical. Now, when you're first entering into considerations about whether or not you might want to do solar on your facility, the first thing you got to think about is what your state level policies are around net energy billing, and whether you can put that energy that you're generating back onto the local distribution grid and receive some sort of compensation for it or not. That really comes down to state level policy. Some of the states that folks might be in, may have a quite mature solar market. And net energy billing is a well understood part of the equation. Some folks might be in states where there is not a net energy billing policy in place, and that could potentially be a barrier to doing a solar project. One other way that solar projects can be done, especially on landfills that have 50, 60, 100, 150 acres of available space, if you are within any sort of proximity to an electrical substation, you may be able to find a developer who's interested in leasing that land to put that electricity back through the substation on a wholesale basis. There can be very few of those types of projects around in your area, but if you've got just the right match of enough land, easy enough connection to a substation, that could potentially be a positive path for you to explore. One other way you can do it is if you have electrical loads that you are using, such as transfer stations that may have a large electrical load, municipal or other types of facilities, then you can potentially wire the solar array directly into those existing facilities, use that electricity behind the meter, even in conjunction with a battery system, possibly export some back out to the grid, but adjacent loads definitely open some doors. I guess the other thing to say is there are different paths you can go down in terms of ownership or leasing. Many of our customers, they are municipalities or utility districts, and they have an interest in owning that solar array because they have lots of electrical loads that they need to offset by using solar energy. The possibility always is you can buy that equipment yourself. You can also enter a power purchase agreement where a third party owns that system and sells the electricity to you at a discount. That's a very common way that renewable energy projects are done in the United States. We can get a little bit more into that later. But when you're looking at your landfill and trying to decide whether or not it's a good fit for solar, one other thing to think about is, do you have access to three-phase power, or is it just single phase going out to the landfill? If you're within 1,000 feet of a three-phase line, that's going to be good for your project. If it's just a single phase service in the neighborhood, that is a serious limitation on the size of the solar array that you could build. The other thing is, of course, when you put a brand new cap on a landfill, there is some settlement that occurs. Sometimes your state regulators are going to be really uncomfortable, with good reason, with putting solar on a brand new cap until that settlement has occurred. So generally, a cap that is 10 or 15 years old or more is probably going to be a better fit than something that's brand new or 5 years old or something like that. Naturally, if you are looking at a project and think that it might be a good fit, there's always going to be a long-term development period where you are dealing with interconnection issues with the utility company and also having the regulators, review the project in terms of environmental impact. So one thing we can say about solar projects, no matter what kind of solar projects they are, they're all eligible for a 30% federal tax credit. And if you're a for-profit organization, you can claim that 30% tax credit as a tax credit on your next round of taxes on the year that your system is completed. If you are a tax exempt organization like a municipality or another nonprofit organization, you can claim that 30% in the form of a direct pay check from the IRS. Still technically a tax credit, but 30% of that project is going to get paid for one way or another by the tax credits. In addition to the first 30%, There are other adders to the 30% that may be available given your circumstances. If you're in an energy community, then you get an automatic 10% addition to a total of 40% tax credit or a direct pay check. And then there are some competitive categories as well that you can apply for, including if you're in a low income community, if you're on Indian land, if the energy is going to serve low income housing, or if there is a low income economic benefit to the project. In addition to the 30% federal tax credit, there is also a depreciation benefit for these projects. They are all eligible for, and this only applies to for-profits. They are all eligible for Maker's accelerated depreciation schedule over the course of 5 years. And so between the tax credit and the depreciation, it can really bring down the investment cost of that project quickly in the first couple of years of the project. The operating costs of the project are very low, especially compared to the revenue that they generally bring in. The solar panels are warranted generally for at least 25 years of power production. Inverters for 12 years. They usually have options for very inexpensive extensions of their warranties too. But according to the National Renewable Energy Laboratory studies, today's solar technology is, after 40 years of operation, still going to be generating at 80% of its nameplate capacity. So these projects, once you install them, have a tremendous longevity. If you are interested in an ownership option, you can always purchase with cash if you have cash on hand. You can always take out a loan as well. Either way, you're eligible for those tax benefits. You know, there are some times that our customers are interested in doing solar, but for whatever reason, they don't want to dedicate their ability to borrow to a solar project instead of some other projects they have in mind, or they do not have the cash on hand, in which case a power purchase agreement is a very common method for financing these projects. Power purchase agreements mean, again, you have a third-party investor who owns that system for at least the first 6 years. The investor claims all those tax credits, and then oftentimes after the first 6 years of operation, you will have an opportunity to purchase that equipment at fair market value, so far reduced from the initial install cost of the project. We've done a lot of PPAs. Most of our landfills have been done with PPAs, and they can be a really advantageous cash flow position. Before the Inflation Reduction Act, in nonprofit and municipal organizations could not claim a 30% direct pay tax credit. And so when that was the case, it was a no-brainer to do these PPAs. Now you are almost definitely going to have a better cash flow, a more valuable project to your organization over the life of the system if you buy it outright or take out a loan. A PPA is third in line in terms of, you know, total savings over the life of the system, but it can be an advantageous cash flow position if you can't come up with the capital in the short term. That's all the stuff I just said about the PPAs. And then, you know, the benefits of solar are, I think, pretty well understood, right? This is an environmental benefit when we do these projects. They create local jobs. You know, many of the pieces of equipment we're installing these days are also made in the United States, but even if they're brought in from overseas, the project still needs to be built by local labor. You get operational savings in many cases for your operation. You get great publicity, great engagement from your stakeholders. You're making use of space that you otherwise can't use, and it increases the energy resilience of your community. So thanks very much. I'll turn it over to Chris.
Brilliantly done. Literally right on time. I was just about to reappear.
Thank
And
you.
if there are any questions for Andrew, feel free to put them in the chat. Chris, you are free to now share your screen. And then I will be concatenating all the questions from the Q&A and everything, and then getting those ready for our panelists. So Chris, the floor is yours. And it is coming in loud and clear on our end. So no
Okay,
technical
great.
difficulties.
See if I can move this. How's everybody doing today? I'm trying to get rid of this little bar. Oh, there we go. Just kind of moves away. So today I'll be presenting a different renewable energy solution at a landfill, which is taking the waste gas from the landfill and converting it into renewable natural gas. So first thing is talking about Waga Energy and who we are. We were founded in 2015, but our founders really came from the renewable gas industry. They worked for a company called Air Liquide, and they took about a decade to develop this proprietary technology and take it to market in 2015. We are publicly traded and we've got about 200 employees around the world. We operate mainly in Europe, North America, South America, and a little bit in Central America as well. So we consider ourselves a global company. We have 23 Wagga boxes operationally in operation around the world, 14 more projects in construction, and we are dedicated to compliance and helping a landfill meet their obligations for methane compliance, as well as make sure that that our facilities are safely operating. Now, in North America, renewable natural gas feedstock is primarily derived from four sources. You've got the food waste area of landfill gas, wastewater, agricultural waste, which is really dairy cow manure, maybe pig manure, chicken manure, things of that nature. And then the majority of the feedstock comes from landfills. And RNG conversions of taking those feedstocks and converting them into a usable fuel has really been on the rise in North America. So you can see on the chart on the right, in 2023, we have about 328 operating projects in North America. Of those, there are about 80 of those projects are RNG facilities from landfills. Now, the key is that per the EPA the EPA has got a great section on biogas and a lot of like tools for us to evaluate renewable natural gas. And so a lot of data is available, and there's three ways to handle landfill gas and do something with it to kind of reduce the environmental impacts. The first is kind of that gray primary treatment area. Most landfills in the United States don't have open storage. A lot of landfills are capped and regulated. If it is open storage, is very small in size, but the EPA is really making sure that landfills meet their methane obligations. And so the first thing under primary treatment is you can flare that gas, but it doesn't really help your environmental compliance. There's no added revenue being generated from that gas. The secondary treatment, and this is kind of it's about a decade old. You can look through the EPA data on generating electricity from a landfill. So it's relatively simple to scrub the gas and generate electricity. But the problem with it is that the electricity generated in most of the markets in the United States is just not as valuable. And so the advanced treatment is really where our technology focuses in on. And that's where you're able to capture a lot more of the energy content and a lot more of the environmental attributes to really generate a much more beneficial use project. And so we're going to kind of dive into how that works. So in looking at a landfill, if you just step back on the left there, you can see a cell. And within a cell, there's a metabolic process happening on the organic waste inside of that cell. And so towards the outer portions of that cell, you have a lot more oxygen infiltration and more aerobic digestion. And as you get closer to the middle of the cell, you have anaerobic digestion, and that's where you're going to really convert that waste product into methane. And so the chart on the right is really describing a variety of landfills. So you see there's 10 landfills, and looking from left to right, starting off with nitrogen, you can see that the nitrogen fluctuates quite a bit in a site. It might be as low as 5% and as high as 30%, depending on the landfill and what's inside of the landfill. And then O2 is relatively low concentrations typically, because again, we have anaerobic digestion, which is in the lack of the presence of oxygen. Then you've got CO2, which is a pretty main gas. And then last and the most valuable, obviously, is the methane. But below that bar graph, you'll see a line graph. And what that is showing is that even though the average of that landfill, let's say one of those landfills averaged around 20% nitrogen, on a day-to-day basis, that nitrogen is really going to fluctuate quite a lot. So it's going to fluctuate for a variety of reasons, from the atmospheric pressure to moisture content. What part of the cell is active. So the gas is in this constant state of fluctuation, and it's more, think of it like the landfill is a living, breathing organism. And so that makes it extremely challenging to take all those variables and produce a viable fuel out of. And so that's how our patented technology came about. Because if you look at legacy technology that's in this space of converting this very volatile fuel into methane, it uses technology that's called pressure swing adsorption technology. And you'll see on the summary report there on the left, you have an initial concentrations of gas that are coming in from the landfill. And using pressure swing absorption for your filtration of CO2, it really does not like nitrogen. So historically, how that's handled is that an operator like us, if we were operating on your landfill with legacy technology, we would ask the landfill, can you tune out well 7 and well 8 and well 15 to try to bring the levels of nitrogen down where you've got a lot of air intrusion inside that cell. And so that just turns into it's a safety risk. It also is an odor risk. So if we're telling you to tune down the well field, then that just means that there's less of a vacuum on the well, and it gives the well more of an ability to off gas. And so the other big result of that is you're going to lose a lot of monetary value. So on the right hand side, the flow rates get adjusted to try to tune out the nitrogen in the well field, as well as the available heat rate, which is really the energy content. And that's important, because that's where the economies of the projects, or the economics of the project, really come into play. So our patented technology takes a little bit of the legacy uh, uh, process, where we still use pressure swing adsorption, but the key difference is that we only use it to remove the CO2. And we also use membranes to remove the CO2, and those are both very industry standard, highly efficient. Where our technology is a bit different is, after all of the CO2 is removed and the H2S and the volatile organic compounds are removed, you're left with CH4, which is the methane, CO2, and sorry, not CO2, O2 and N2. And we use a cryogenic distillation. So what that means is the gas enters the chamber, and we first vaporize that gas. So we expand it really quickly under pressure, and that drops the temperature really, really fast. And then we add a little bit of liquid nitrogen into that chamber to further drop the temperature down to minus 260 degrees Fahrenheit. And what that does is it separates the CH4 as the liquid will drop to the bottom, and the nitrogen and the oxygen float to the top and can be pulled off the top of our equipment in that cryogenic chamber to get basically destructed in the thermal oxidizer. And then the liquid CH4 goes through a heat exchanger, and then that basically gets regasified, repressurized, and injected into the pipeline. And one common misconception about this is that people think or typically ask us that, how energy intensive is this process? And this process is actually less energy intensive than using legacy technology to try to remove nitrogen and oxygen, simply because the nitrogen, oxygen, and CH4 are all relatively the same size molecules. So using pressure swing absorption and membranes to filter those molecules away from one another means that you have to cycle it many, many times, and you can't remove it all. Whereas this process, because it's in a containerized chamber, is really easy to keep at temperature, and it separates the molecules very efficiently. Some of the last things here is just talking about our plant in general. Just walking you through it. As the landfill gas comes in, we remove the H2S. H2S is removed by activated carbon, and then we have the VOC removal in section 2, as well as the CO2 separation and polishing. So that's going to be done by membranes as well as the pressure swing absorption, like I talked about before. And then our patented technology is number 5. That's the cryogenic chamber, where we remove the N2 and the O2. And lastly, we regasify, and we send that gas into pipeline. We do have a thermal oxidizer, as I said. That's going to take all of the waste gases from the various parts of our process, such as the CO2 and the N2 and the O2, and it's going to basically oxidize those, or just release them into the atmosphere. Then we have a backup flare, which is required by law, and is required by permit. So in case everything breaks in our facility, we have that backup flare. And then the last part is C. That's the electrical room to provide power to all of our equipment. The way our team typically operates is that we are what's called a DBOOM. So we develop, build, own, and operate model. But one wrinkle is we also manufacture. So what we typically do is that, because we want to own and operate our own equipment that we manufacture, we really want to partner with landfills, and in a way that allows the landfill to continue focusing on their operations, continue to work on the well field and the well field management, and then leave the gas processing to us. So usually that's gonna work under what's called a royalty agreement, whereby we both have between the landfill and WAGA, we both have an arrangement where we're both incentivized the same way. So we want to process as much waste gas as we can, to ensure that both parties receive as much royalty as possible. This slide really focuses on just our uptime. So if you look across, these are WAGA boxes that have been in operation. So kind of talking about the operations of the equipment here, we do have a 95% guaranteed availability. That includes planned and unplanned maintenance. We're going to have dedicated staff to your facility and to your landfill, and we have got great record of uptime, and then obviously we're heavily involved in the project's overall success. Here we've got just quickly show 23 Wagga boxes that have been in operation. 14 more are in construction. And in North America in particular, you can see we've got 5 projects that are in operation. Another 10 projects are in construction right now. So this time next year, we should have about 35 projects or more that are going to be operational. And just to quickly go back and reiterate what makes a successful RNG project at a landfill, it's really a partnership between the landfill and the operator of the renewable natural gas facility. So we want to ensure that the landfill is meeting all of its compliance obligations, that there's flows, and the well field is healthy. And then from a technological standpoint, I think a landfill really wants to make sure that a partner isn't going to get too involved in the well field operations. You, like I said before, using those legacy technologies, you really have to have a lot more coordination between what wells are operating and what wells aren't operating. So again, from our technology, you don't have to do that. And then the last part is really in looking at the gas utility as well as the offtake. So working with the gas utility, ensuring that the pipeline to get the gas from our facility interconnected into the pipeline, working with the utility and making sure that we meet all of their obligations for the gas constituency. And then looking at long-term offtake partners. So that's going to be working with large organizations. Those could be municipalities, whoever has a required obligation for lowering their environmental footprint, if you will. Those are all people that could potentially be interested in the gas that we provide. And recently, we inaugurated a facility up in Steuben County, New York. If anyone on the call is interested in looking at this site, I think one thing that really stood out about the development of this project was it was a lot of stakeholders were involved, and there was a nice bridge between a public and private partnership that enabled a successful deployment of our project. And that's it. Thank you very much for having me, and here to answer any questions that anyone has.
Awesome. Thank you, Chris. No, this is super informative. I never studied methane gas and or renewable natural gas capture, so I was definitely like taking notes and as I went along. It was very informative on like the process that it goes through. Because in my naive opinion, I just thought, oh yeah, you just hook a hose up and the gas vents out and it's good to go, right? So it was definitely a huge, learning experience. So with that, I actually, Chris, while we're on the topic, what kind of permitting, requirements should someone who's looking to roll out with something with what you offer, what kind of permitting requirements they need in place? Does the landfill, like, Andrew talked about where the landfill has to be settled to a certain degree before you can really start, building on top of the cap, what kind of obstacles they face when having to roll out something like this?
Yeah. I think, kind of starting from the top, the first thing to consider is, are you accepting enough waste to even have it be a viable project? And usually that cutoff point is about 150,000 tons per year. And then once you know that you're accepting enough waste, permitting wise, I mean, really it's all about air quality, making sure that we don't avoid any of the existing permitting or encumbrances. but really it's a lot more on the interconnection side. So permitting is local, working with the local AHJ, and those things kind of like just kind of follow their natural course. But really where a lot of the industry, I won't say the word struggle, but it definitely is the most difficult part of the project, is ensuring the utility interconnection, and working with the local utility and ensuring a successful interconnection is being developed in the same timeline as your permit is definitely things to consider.
Hmm. Great. That's honestly that's great to know. Andrew, I have a question for you. So in terms of we talked about, I studied renewable energy specifically. I specialized in solar and wind when at my undergrad. I was a mechanical engineer in a former life before I fell in love with the solid waste industry. When we talk about, net metering, I'm very familiar. I know, like Germany, for example, when you called it out, they have a buy all, sell all scheme. So you're forced to pump into the grid. You know, navigating, I like to joke that New Hampshire is the south of the north, where they have very different policies relative to their neighbors. And one of them is net metering. How do you navigate the difficulties of, power companies, regulations where, there might be a limit on the size of the structure you can put in? What kind of devices do you have at play here to really change, like, kind of call an audible and be like, look, if net metering is going to be an issue, we can do this instead. What are some of the devices you have at play there?
Yeah, great question. Well, I think the first step, if anybody is interested in pursuing, a solar project on the landfill, is to get in touch with, a reputable solar company, preferably a company that develops, designs, and builds the solar arrays, to help guide you through the process. I understand lots of folks here probably have procurement rules, which means that they're going to be asking for help, but they can't make any promises until they have a project that they can actually release an RFP for. I know that in the case of Revision Energy, we are always happy to be the first company through the door in order to guide people to that process, because the last thing we want, and the thing that is the most frustrating to see in our industry, is somebody who puts out an RFP for a project that, doesn't have an understanding of what it is that they're really asking for, and trying to get competitive bids on something that, they're frankly a little clueless about, is a very difficult position for developers, designers, and builders to respond to. So I'm sure that in your community you can find a reputable solar company, or if that type of company isn't around, at least a developer or a consultant who can help guide you through that process, can explain what the pitfalls of your local net energy billing program are and how to finesse it. Generally, a utility company will require you to file an application in order to determine what your interconnection status is. A lot of times that doesn't come until you've already selected a partner, arrived at a design. And so you sort of do have to put a little work in on the front end before you find out whether the whole thing is viable through interconnection. Lots of times the utility company will come back and say, well, your project can be built at this size, but it'll cost you X amount of money, to pay for the grid upgrades that are required to interconnect your project to the utility grid. Sometimes that includes additional transformers at the substation level. Sometimes you got to run a new conductor from the substation to your facility. These are important grid upgrades that the utility company will probably end up having to do one way or the other in the next 50 years to feed new growth electrical loads, but they will shift that cost onto your project. And a lot of time the project can bear those things, but when it can't, then sometimes you need to have a conversation with the utility company to say, how much do we need to downsize this system in order to get past some of these requirements that you have. And some utility companies are more open to that conversation than others. To be perfectly frank, some utility companies are simply regard distributed generation projects of any kind, be it solar, wind, or anything else, as something that they're hostile to, and they'll do what they can to stop you from doing it. Again, your local solar professionals will understand how to guide you through that, which is probably the biggest set of risks and the most difficult part of developing these projects.
Very, very well answered. It's a very, I know, we always like to joke, Chris, I don't know if you come across this, but NIMBY, not in my backyard. A lot of that, I know solar and wind face that at a very large amount where everybody wants to help the planet, but not when it's in their backyard. That's the catch. I know, Chris, like where you're going on to, landfill sites is a little bit different where, it's kind of already there, so you might not have to deal with that conversation as much. If anything, you're alleviating that issue. But you know, Andrew, I feel that a lot where a lot of people, and I think all of us in the solid waste industry understand NIMBY a little bit too much, where everybody wants some place for their waste to go, but they don't want to have to be the one to look at it. Um,
Hmm.
and sadly, solar gets grouped into the same thing when it's doing something very beneficial for the environment. Um, I have an innovation question for the both of you. So, are there any upcoming technological innovations that you believe will further revolutionize the renewable energy landscape, in more specifically in solid waste management? And this could be a technological leap, or this could be a policy leap as well, as I know policy can often hamper innovation in some instances.
Yeah, I mean, I think both Andrew and I would love to see some policy innovation for standardized, approvals on the interconnection side as it pertains to a utility, or even on the at the AHJ, um, where they could have a standardized set of plans. Um, that would definitely help quite a bit.
Absolutely. Andrew, I see you pondering this one. Why you think of an answer? Sue says now it's bananas.
I was reading Sue's comment. Yeah, hilarious.
Yeah, and it's funny. NIMBY people are like that kind of sounds like it'd be offensive to somebody, but then bananas is like it's actually bananas to think like that, where you want things but you don't want to have to do the things to get the things. Um, I feel like that's a very American issue from what I have found, but I think it happens even in New Zealand. When I studied there, they had some similar issues where people are very tied to the environment there, so they don't like things changing very much.
Mhm.
But Andrew, anything to add on the innovation side?
I'll say, solar photovoltaic technology, was the first time it was invented was in the 1880s. The type of technology that we use today was, basically invented in the 50s, and has been, continuously advanced since then. And the thing that has, fundamentally changed this industry is in the last, 10 years, we have reached global scale of production, which means automation, efficiency, and it has vastly reduced the costs and vastly increased the efficiency of each solar panel. And that really, in terms of game-changing innovation, it's not going to happen in solar collection. I think we all hope that someday, we'll have, cold fusion, or, some sort of, fusion technology will come along that is clean and easy and safe, and, generates, unlimited energy for virtually no cost. Every estimate I've ever heard for my entire life was it's 50 years off. They said it was 50 years off 30 years ago. They still say it's 50 years off today. And so I think, the bananas comment is absolutely, to the point, which is that, to reach 100% renewable energy is going to require, and the nice thing about 100% renewable energy is solar and wind is so much cheaper for supplying energy than any other form of, fossil fuels. I'm going to leave Chris's industry out of this comment, because I'm sure that you make a very inexpensive product too, Chris. Um, but in order to bring that to market in a way that, is resilient, is, a steady supply of energy over time, we can't do it all with batteries. We're going to have to build big transmission infrastructure projects across the whole country and internationally, to get hydro from Canada and other sources of energy, renewable energy. Those projects are wildly unpopular. If you're in a state and you're hearing you want to build a transmission line from this wind belt state in the Midwest out to the East Coast, and this is going to travel through our state, that is very unpopular with people. Infrastructure projects are very unpopular these days, which continues to blow my mind because it feels like short-term thinking. So if there is some way to get the, public consciousness to open to the possibility of new infrastructure and delivering a country that is ready for business and ready for life the way that the country was delivered to us in our generation, and deliver that to future generations. I think that's the innovation that we need.
Hmm. Very well said. It reminds me in Iceland, they actually produce 103% of their energy requirement every year.
Mm,
And they have actually the potential to make enough energy that they could build a pipeline to the UK and supply the UK its entirety of its energy. So they're one of the
mm,
few net exporters of energy. But it's such a hot topic for them because they're very naturalist that they will not disturb anything that they don't have to, which I do respect that totally. Like we've met our own needs. We don't need to meet other people's needs. It's outside of our scope. But it's very, very interesting the fact that I think the biggest barriers all of us face right now, and judging by both of your presentations, it's more of an issue of, I guess, political will or like popular opinion rather than technology. Which, if you ask the same question 30 years ago, people would have said technologically this isn't feasible yet. But the will was there. The will to get to the moon was there 40, 50 years ago, which seems Herculean, but the technology wasn't, and now it's the reverse. But the technology is here, but now nobody wants to do it, which is a very odd position to be in. I'm just reading in Sue's comment. Uh, yes, organic conversion technologies. That is a very hot topic right now. Because Andrew and I are both New England based, we would see organics and think like, yeah, compost, like it sells like hotcakes. But Chris, from my understanding, I've talked to a few people on the West Coast, and finding end markets for compost has been incredibly difficult recently. Um, where they're trying to create composting programs, but the end result or the end product isn't as viable, which is why RNG is, I guess, increasingly popular out in the West Coast as well. And any insights on that, as I know you're much closer to composting than Andrew or I.
Yeah, I think some of the challenges with composting is PFAS, and trying to get the PFAS out of the organics has been tricky. So, I think trying to get something that is ultra pure is has been challenging, but I think that as policy grows out of California, we have organics diversion here
Mhm.
in our state, and I'm calling in from California. I think that it will solve part of the problem, but it won't solve all of the problem.
Mhm.
And I think that you have not only do you have a way to process the organics to make it into a compost and have a use for it, but you also have to have people in the public want to comply to send their organics. And so there still is a tremendous amount of organics that are ending up in the trash in the landfill, even with mandatory organic diversion in place. So,
Absolutely. And, and
yeah.
it's great to know that, with RNG capture as well, we're obviously everybody wants to make compost, but where we still have that infrastructure, if you're receiving a clean stream, that it's much easier to kind of hit those purity and get something out that's pure when you might not be dealing with so many variables with what was thrown away in, say, 1940, where God knows what they were throwing away at that point. Um, because horsehair plaster and I've gotten far too accustomed with it working in antique apartments in Cambridge, which is like 1870s construction, where you open up a wall and somebody goes, "That might be asbestos." I'm like, "Thank God I got my mask on today." And I can't imagine what that does from a purity perspective on
Yeah.
gas capture, which I tip my hat to the level of technologies that are coming through. Um, just one more, Sue. Actually, I appreciate your next call. I agree. Everybody wants zero emissions, and no one trusts the environmental agencies. This is something that's been I know with PFAS, that's been a huge one because there's a PFAS contamination in my town's reservoir, and that's a big issue. Where this was something that I think people felt a little bit betrayed by environmental agencies, that it wasn't as regulated as it should have been back then. And it causes where we're trying to do the right thing now, we've lost the public trust in a way that we can be enabled to do the right thing. And I believe that's very difficult. Um, Yeah, and no, again, bananas again. Nobody wants to have the technologies to fix the problem they're worried about. Um, and then just one more question for you both. Um, I already asked my policy questions. So, so what kind of collaboration do you feel? What kind of structure of collaboration works best in a rollout for each of your technologies? You both alluded to it a little bit, but I'd like to hear more about like what kind of partnerships between, we've heard public and private, nonprofit, for profit. What of those have you seen be the recipe for success? And that is to both of you, so whoever wants it first can take it.
I would say so. I think 100% of the landfill projects that we've done at Revision Energy have been a partnership between Revision Energy and a municipality. We have yet to do projects with for-profit waste management companies, which is an exciting area that we're looking forward to cracking into. But so far, we've got a great track record with municipalities. You know, municipalities in our area, they tend to be a bit land poor. Just because of the geography of the state of Maine, state of New Hampshire, and the density and the high value of property in Massachusetts, which we're starting to see up here too since COVID. I know everybody in rural areas is singing the same tune about that. And so, they want to hit their renewable energy goals. They're very happy to, find that there may be an option on a landfill. As I've described in my proposal, we have a whole array of different, financial options, and we can usually find a good fit. Municipalities are marvelous partners for us. I think that's about all I've got to say.
Brilliant. Chris?
Yeah. So for us, a lot of the same sentiment. I think we have a little bit more of the community that needs buy-in on our project, as well as a municipality or and as well as the landfill. So we really work to work hand in hand with the landfill to do all the public outreach that's necessary, bring in all the external stakeholders from the utility, from the local jurisdictions, make sure that we're passing all the compliance. And then really, our structure with the landfill owner is it's more, it's usually an LLC. We'll create an LLC for our facility where each one of us will have an ownership of the LLC and then receive royalties from that. So that's kind of the world that we live in a nutshell. So we're just looking to be good stewards and be good partners for everyone.
Awesome. No, that's super interesting. The fact that each deployment is its own LLC. Now that they're actually selling power to the grid, that actually makes a lot of sense now that I think about that. But I never would have thought you need to form a separate entity for a specific site on top of another site. That's actually very, very interesting. But with that, I guess, any closing comments or remarks? We reserve a little extra time. I know I want to be respectful of both of your time. Um, but yeah, any closing remarks? Anything you want to share last minute?
I'm just happy to
But
be here. I spent most of my career in solar, not on the gas side. And one interesting thing was, energy can be converted right across joules, calories, whatever. And one thing I always thought about every time I see a solar panel is the amount of energy is, if you were to compare it in the southern states, it's like picking up a 50-pound weight from the ground and lifting it up to your waist and then back down to the ground every basically 1 meter per second. A 50-pound weight is the equivalent energy of a solar panel for 5.5 hours a day. So you'd have to kind of keep that pump jack motion going for 5.5 hours a day to equal one solar panel. And on the gas side, it's just amazing how many homes or businesses can be powered from our waste. And so really, I think the theme of renewables is there's always a better way
Mhm.
to make energy, and so we're just finding better ways to be a more efficient society. So that's kind of my my last message, I guess. As well as reach out if you have any questions or if you have a landfill. I'm sure my contact details will be provided. So yeah, happy
Absolutely.
to help.
Andrew, I see you nodding along as well, so the floor is yours.
Awesome comments. I love the engineer's perspective on the transference of energy, from one form to another. That's really cool, Chris. I guess I would end by saying, if you're interested in doing a solar project on your landfill, um, one of the things that I always have to sort of thread the needle as a salesman to give people a realistic expectation of what the development challenges are going to be without scaring them away from the project. There are lots of things that will come up during the development of your project that will make you feel, oh, maybe this isn't going well. I would just urge everybody anybody who goes down that path to please stick with it. Be have grit and continue pushing forward through development challenges. Get that solar project built if ever you can, because it's going to be here, for 35, 40 years generating electricity. We tend to look at things for every good reason in terms of short-term financials, making sure that things work in the first 5 years, in the first 10 years. But, most of the people who are here are working at organizations, be they for profit or municipal or others, that will be here 40 years from now and 50 years from now. And so these long-term investments are just of an extraordinary value to your organization and your community. So please don't be discouraged.
Yes, that's very well said. Andrew, you talked about the land crunch in New England. Everybody used to balk, like, really get like, offended at house prices back in the day where I am. I live like 20 minutes outside of Logan. Fun fact, Burlington, Massachusetts. Amy Poehler is from here. And so Paul Blart Mall Cop was filmed here. So I know that's everybody's favorite piece of cinema, but that is what my town is known for. My grandparents moved into my hometown in the 1950s, 60s. They paid $16,000 for their house. We sold that same house after they passed for almost $800,000. My parents bought a house when I was born, and for around $225,000. That same price of that home is now $2.2 million. Um, it's not like these long-term investments are never going to get cheaper. George Washington said it best. He goes, "The best time to plant a tree was 20 years ago, and the second best time was now." So do
Yeah.
it now. um, and Julie, yes, the attendance. Andre is on the call as well. He handles everything for HQ attendance. All of those things for continual learning will go will be accounted for. But I implore you all, if you're thinking about renewable energy, now is the time to do these things, because when they pass new policies like infrastructure, what Biden passed and what predecessors have passed before, when you're ready to go and seize on those funds, because I know CalRecycle just put it in RFP with a 3 week notice. That is a lot of time to put things together. When you have proposals from gentlemen like these two ready to go, it just makes you stick out on top of the pile. So always recommend being prepared with renewable energy whenever you may need it, because the time that we're going to need it is very soon. And with that, thank you everybody for tuning in, and thank you to Chris and Andrew for a wonderful presentation. I learned a ton. I feel like I'm back in college. A lot of new wrinkles in the brain. And this will be recorded, so anybody who couldn't make it, we're happy to distribute and share it. And then Andrew and Chris as well, we're happy to share the recording and any blog content we put out. We'll be sure to link you guys in it and share it for your own sites as well.
Also, I want to give Sue a gold star for engagement. Your comments were really appreciated, really awesome. Thanks, Sue.
Yeah, thank you, Sue. We'll be sure to share. And actually, the recording and these types of things should go direct to your email as a registrant. So you'll get a copy of that as well. So please feel free to share. We're always happy to spread the knowledge and spread the wealth. And with that, I will be here if there's any last minute questions. But thank you, everybody. This was lovely. Learned a lot, and enjoy the rest of the day. It is sunny in New England, so go enjoy the sun as well, if it is sunny by
Thanks,
you.
all.
Yeah. Thank you, Andrew. Thank you,
Thanks,
Chris.
everyone.